All right, so the first section that we're going to talk about here is section 1.1 and 1.2 in the book. And so we're going to talk about limits. And so the first thing we're going to talk about here is just, can a change occur at an instant? Okay, so we have Mr. Brust's distance from his house is modeled by the function d of t. While riding his bike to the store, he realizes that he dropped his wallet and turns around to find it. After finding his wallet, he finishes his ride to the store. So when we're looking at our graph here, he's traveling. So traveling, turns around, and then starts traveling again. Okay. So the first question is, what is his average speed? And average speed, anytime it talks about average speed, you're talking about just rate of change. And that's the same rate of change that you talked about in Algebra 1. So what is his rate of change for his trip to the store if he arrives after 8 minutes? So we're talking about the entire trip. So what we're going to go back to is we're going to go back to a little bit of Algebra 1. So that change in y over change in x situation. And so when we're talking about y values here, we want to figure out the y value at 0 seconds and the y value at 8 seconds, and that's what we're going to put on the top of our fraction. And so we're going to say d of 8 minus d of 0 over 8 minus 0. So that's our change in y. So if I have my two y values and I subtract them, I'm going to get the difference between the two over that change in my x values. So what that's going to end up being is d of 8 is 1300. D of 0 is going to be 0. And I'm just figuring that out by going, okay, here I am at 8 seconds. If I carry that up to the graph here, what is that number? So that ends up being 1300 there. And then we have 8 minus 0 on the bottom. So 1300 over 8, and that is 162.5 meters per minute. Okay, so 162.5 meters per minute. So then we look at these other questions. So that is his average speed for this entire distance, okay? And that's even with him changing directions and going back. So if we wanted to figure out more accurately kind of what was his average speed when he did his change between 2 and 6 minutes, we're going to look at basically the same thing. So we're going to do d of 6 minus d of 2 over 6 minus 2. We don't have to actually figure that out. I just really want y'all to see the process of it. And then here, what is his average rate of change between 2 and 3 minutes? So same thing, d of 3 minus d of 2 over 3 minus 2. So next part here, Mr. Kelly has decided to quit his job as a teacher and be a social influencer. The number of views on his new channel is modeled by the function v, where v of w gives the number of views and w gives the number of weeks since he started the channel for 0 to 26 weeks. The graph of the function v is shown on the right. So we have our graph. First thing it wants us to do is draw a tangent line at w equals 10. And so what a tangent line is going to be is it's going to touch only one time in a specific point. Okay, now that can be kind of confusing because like if this graph, like if it continued on or whatever, then technically, if we continued this line, it would touch this graph, the red part of the graph. But we're focusing on touching the graph at one specific point kind of in this area that we're looking at here. So we have W equals 10. So let's draw this line. Okay, something like that. Now, remember that you're getting an estimate of the instantaneous rate of change. This is not going to be super accurate, especially if we don't draw our lines straight and things like that. So when we're looking at instantaneous rate of change, okay, what that is meaning is how fast is something going at that instant, okay? So at this point right here, how fast are we going? And so to figure that out, what we can do is we can find the rate of change of this tangent line. And so if we're thinking back to algebra, rate of change is rise over run. So the rise is 200. This run is going to be 15. So we'll have 200 over 15, which is approximately 13 views per week. Okay, so when you see these squiggly equal signs, we're talking approximately is what that means. All right, give an example of how to calculate a rate of change that would give a close estimate to the instantaneous rate of change at W equals 5. So if I'm trying to get something that's a really close estimate, what I can do is I can take two numbers that are very, very, very close to each other and find the rate of change between those 2 points, and that should give me a pretty close estimate of what I'm looking at. So we're looking at right here where we have 5, so we're looking for that instantaneous rate of change there. So what we can do is if my points are 5 and then something really close to 5, and I find the slope there, I'm going to be more accurate as far as what my rate of change would be. So let's pick 5, and then we can use something like 4.999. So it's the same concept, my change in my y's over my change in my x's. So a lot of that is just basically a little bit of review from Algebra 1 and some other things like that. Okay, and the next thing that we're going to go into is using a table to estimate a limit. Okay, so we have f of x equals x cubed minus 1 over x minus 1. And so essentially what this is this is going to be some graph that has some, point. So it says the graph of f is a parabola that has a gap at the point 1, 3, as shown in the table. So we don't know what that if we try to pick out this number right here, when we plug 1 in here, we're going to end up with 0 on the bottom of our fraction, which is going to be undefined. So there's going to be a hole in this graph if you actually graph it. And so when we're finding limits, what we're finding is if I get, coming from the left side and the right side of that point, what are those two sides approaching? And so if I'm approaching from the left side and the right side, what number is it that I'm approaching on the graph? Okay, so it says although x cannot equal 1, you can move arbitrarily close to 1. So that's what we're talking about, the two sides. So like let's say I had a graph that looked like this, and maybe this is the point. As I move along this graph from each side, what is this number that I'm approaching? Okay, that's kind of what we're talking about when we're doing limits. So in this particular graph, if we look at this transition from left to right and from right to left, and we look at how these numbers are trending, it looks like they're trending towards 3. Okay, so what we would say is when we write this limit, the limit as x approaches 1 of f of x is going to equal 3. So when we say this, we say the limit as x approaches 1 of f of x, and that's going to equal 3. One thing that we have to really focus on when we're talking about limits is the fact that the limit of something and the physical point that's on the graph may not be the same thing. And when we look at some other graphs, that'll make more sense. Okay, so let's look at the next page. Okay, so here's the next page, and it's the same concept here. We have these points, we're going to fill them in. So on your actual homework, you're going to have to fill the points in yourself. So it gives you the x value, plug it into your calculator and get the y value. And so we can fill this in. For time purposes, I'll just fill this table in because we should know how to plug things in. So this is 1.99499. 0, we don't know. And that's if we plug 0 in, we're going to get an undefined answer. Okay, so remember we're looking, what are we doing from the left side and the right side, and what is it that we're trending towards? And is that number the same thing on both sides? So if we look at this, we can see that as we go from left to right, we're getting very, very close to 2. And then as we go from right to left, we're also getting very, very close to 2. So the limit here is going to be 2. Now, there are some limits that fail to exist. Okay, so instances where we can't take the limit. And here are the 3 instances. Well, 3 of the instances. So first thing is different left and right hand behavior. So a limit cannot exist at a point if we do not have the same number that we're approaching from the left and from the right. So like if I have a graph like this, and I'm trying to take the limit at this point right here, I can see that as I approach from the left side and as I approach from the right side, I'm approaching the same number. Okay, when I look at this graph up here, as I approach from the left side and as I approach from the right side, I get 2 different y values. And those 2 different y values is going to make it where this limit does not exist. Then we have unbounded behavior, so that's where both sides are trending to infinity and it's unbounded. And then the last thing would be oscillating behavior. So it's just oscillating between 2 fixed points forever. So can't really get the same thing from the left and right side. All right, so for this particular part, as x approaches 2, f of x is going to approach 1. Okay, and let's explore this. So when we're looking at as x approaches 2, so I want to go to my x value on my graph, and I want to see, okay, what's the y value there? So I'm gonna put my dot here at x equals 2. And what I want to look for is I want to look for the left and right side behavior of this. Okay, so as my x value is approaching 2, what is my y value approaching? Okay, and so here we have the limit as x approaches 2 of f of x. Okay, and so what we want to check is from the left side and the right side, what is that y value that we're approaching? And is it the same thing on both sides? And so when we look here, these graphs are both approaching this y value of 1. So my limit there is 1. Okay, and then the next thing that they ask is f of 2. That's not asking for a limit, that's just asking for if my x value is 2, what is my y value? Well, on this particular graph, they are the same thing. There's a physical point there, so f of 2 is 1. Okay, and then when we look at this next graph, the difference is we have this hole in our graph right here. So the limit as x approaches 2 of f of x. So we want to think from the left side and the right side, what number, what y value is my graph approaching? And so here, that number is still 1. We're still approaching 1 here. So 1 would be my answer for that one. The difference here, though, is when I try to do f of 2. So f of 2, that is asking me what is the y value when x equals 2? Well, there's a hole in our graph here, so there is no y value there. So we're going to say that that does not exist, or it's undefined. You don't need to put both things. Most of the time I'll put does not exist, but I just want you to kind of put it together that those two things are the same thing. Okay, last graph here is we have a hole, and then they have this point up here that they've written. So the limit as x approaches 2 of f of x. So same concept. As I'm approaching 2 from the left and right, I'm still approaching 1 from both sides. So the limit is 1. Now, what is the physical point? What is the y value that you get when you plug in 2 for x? That is this point right here, because there is a hole on this curve. This actual point, that is going to be your answer. So 3 would be our answer there. So the biggest thing with all of this is understanding the difference between a limit and just, plugging in x and y values, so function stuff. Okay, so then use the following graph to evaluate each problem. So the limit as x approaches 1 of f of x. So we want to go to where we have an x value of 1, and I want to see as I approach from the left side and the right side, what y value am I approaching? And is that the same thing? So it's the same on both sides. I'm approaching -1, so -1 is going to be the answer there. I would like for you to pause the video and then try to fill these in yourself, and then come back and watch and check yourself. Okay, so the next one here is f of -3. This is not asking for a limit, it's just asking what is the y value when x is -3. So if we come over here to where we have an x value of -3, there's a physical point right here, and that's the one we need to look at. That has a y value of 0, so we're going to have 0 there. Then we have the limit as x approaches 2 of f of x. So x value of 2, I want to look at my graph from each side here. So I have a curve and a curve. So the limit as x approaches 2 of f of x is going to be 2. F of 2 itself, though, that's this point, is going to be 3. Then we have f of 1. F of 1, there is no physical point with an x value of 1, so we're going to say that that does not exist. Then we have f of negative 2, so if we come over here, x value of negative 2, come look up here on the graph, this is an actual point, so that'll be 2. And then the limit as x approaches 0 of f of x. So looking at where we have this x value of 0 here, and I want to see what is the curve doing from each side. Well, both sides are trending towards negative 2. So the limit is negative 2. Then we have limit as x approaches negative 3 of f of x. So we'll come over here. Negative 3 is right here. If we go to the graph, what am I trending towards on the both sides? And that's going to be 1. This is going to be an important piece, is understanding kind of how these limit graphs work. The next thing, so not only do we need to be able to evaluate just like a limit itself, but we also need to be able to look at limits from individual sides. So from the left side and from the right side. We'll talk about that stuff a lot. And so in this first example, it says the limit of f as x approaches 3 from the left side is negative 1. Okay, and so what that means is if we're looking at this x value of 3 right here, I have two sections of graph here. And I need to know which one I need to follow. And so this wants us to go from the left side. So from the left side, as I'm traveling here, from the left side, the y value that I'm approaching happens to be negative 1. Okay, now if I just tried to take the limit here, like the overall limit, we'll get to that in just a second. So this notation when I write it, so if I'm going to write the limit as x approaches 3 from the left side, I'm going to add a little negative here after the 3, and that's going to tell me I want that limit from the left side alone. And that ends up being negative 1. Okay, so then when we take our limit from the right side, so that's this other side, this is actually approaching a different number. The y value that we're approaching here is 2. So when we say the limit, so as we approach 3 from the right side, that's the positive side, I'm going to put a little plus sign, and that's going to tell me that I'm just talking about that right-sided limit. And that is going to be 2. Now, if I'm talking about just, if I'm talking about overall, the limit as x approaches 3, and I'm not talking about one side or the other, well, the left side of this and the right side of this approach different y values, so this limit would not exist. All right, so last one here. The limit as x approaches negative 2 from the left side. Okay, so we want to go to negative 2 here, an x value of negative 2. And I want to look at the graph from the left side. So the left side of this, what is that approaching? Well, that y value that it's approaching there is 1. Okay, the next one, limit as x approaches negative 2 from the right side. Okay, so now we have from the right side. So we're at negative 2 again, but this time we're approaching from the right side. This is going to approach negative 2 instead of 1. Therefore, when I need to write the limit as x approaches -2, the left-hand limit and the right-hand limit are different, so that limit does not exist. I would like you to pause the video and do the next 6 real quick, and then check your work. All right, so limit as x approaches 1. So that's right here. So when we look at our graph, left side and right side are approaching the same number, and that number is 1. The limit as x approaches 0 is going to be -2. The limit as x approaches 3 from the left side is going to be 5. So we can talk about that one. 3 is right here. So if I go up to that point on the graph, if I'm looking just this left side, 5 would be that number up there. The limit as x approaches -1 is going to be -3. And then here they're trying to throw you off. You've talked a lot about limits, and then all of a sudden you just do f of 1. This is not asking for the limit. It's asking for what is the y value when x equals 1. Well, when I come over here at an x value of 1, there's a hole here, but I have this solid dot here. So that x value, or that y value, is going to be -2. And then f of -2 is going to be 1. Make sure that you've copied these notes down, and you need to keep them.